So today we are going with the chemistry. Let me tell you one thing. When we just get the word matter, this means we are specifically talking about the chemistry. That could be anything related to chemistry, the branches, or any important topic. Okay. So if I'm writing chemistry, and here's the matter. Matter. Okay. So now what is matter? Matter is composed of atom. Okay. Now what is mean by atom? Atom is like not like divisible or not to cut, cannot be divided further. Okay, that was said. But let me tell you, after that, indivisible, like it was told in previous researches, like in the old, I'm writing old era or like old days, it was said that it cannot be further divided. This is like the smallest particle, very small particle, or very smallest. Even we cannot call this as a smaller or small. Let me tell you the reason here. If we talk about, if I'm just writing small, this means still the question arises, why is not smaller? Like small, we have anything small, we write it small. But what we have like very small, then smaller, we have very small, like that is smaller. Still now the question is, we also have the like still smallest thing would be there in this world. So that's the reason we directly call this as the smallest, just because the third form of like verbs or anything. And this means that there's nothing more smallest than this in this universe. So that's the reason we cannot even call this as a small, we cannot call this as a smaller, but we can call this as a smallest, which is right. Okay, so this is individual particles. In the old era it was said that it cannot be further divided, but like latest researches as told, like this is the divisible particles, which means it can be divided. Like previously it was said because they just found it a small particle and they thought like that cannot be divided, but now it has been told that it is a divisible particle, which means it can be like divide. Okay, so now what is divisible? This means it can be further divided into smaller particles, into smaller or fundamental particles. Now what are the fundamental particles? So just what are the fundamental particles? Fundamental particles. Okay, so now if I start, as everyone knows, we have the three fundamental particles: electron, proton and neutron. So first we are going to define electron, which is denoted as a E. This has a negative charge. And how is this written? Like in which form it's written? It's like 1e or 0. How? Just because electron is like very low or very having very highest mass, but by 0. Let me tell you. Okay, 0, like this 0 is showing they have low, what they have very less particle, very like smaller particles which have very less mass. Okay, this means lightest mass is also like known as, this 0 is denoting as a lightest mass. Okay, that's the reason this can revolve all around the orbits very easily, revolve around the orbits. Not only this, the example could be, and let me tell you one thing, energy, and like energy shells are there. Of course we can call the orbits as a shell as well. So the energy is there, like which allow electron to revolve. Okay, so this is the same point as the above, but let me still clarify. The energy is used to move, like when electrons move, it's using its energy. Just because it's a lighter particle, it does not require more energy, but still it's required. And the example could be any wood particle as well. So this was about electron. If we talk about the proton, so what is this? That's like first, if it, as everyone knows, if it's have a negative charge, proton is have a positive charge. How it's written? It's like written 1p so one p and one on the above, but this one shows there's like one is a charge, we're showing it's a charge. And what about if we talk about mass, here it was lightest mass, here it would be normal, like not very like good or not very high, not even very low, so this means normal mass. And so example could be concrete particle as well, concrete particle. If we talk about the last, which is neutron, neutron, that is like the high mass, of course. If we talk about this, it is revolving, it's a very small mass, it's having like normal like as we compare solid, liquid and gas. Solid have a very like combined particle like attached together, and the second liquid have normal, like not very close, not very packed. Or in the liquid same, like we have separated. So here this means it's at a high mass, this is less, and this is the normal. Okay, high mass, and the example could be any iron particle. So this was about the fundamentals. Now if you go through the structure of atom. Okay, so what are the structure, or if we talk about structure, firstly structure means a position or its composition, how it's made, how we human beings are made up of atoms. Like we have two eyes that are placed on its own place, like the place we have, everyone has the same two eyes, everyone has the nose, everyone has the lips, everyone has a complete body. But still, like this means these are divided equally, or the composition or the structure shown, that shows. Okay, so now if we talk about here the like what's the position, or if we need to find position, find position of an electron. This is one electron which have zero charge, as we know. One, like this is one positive one charge plus, or this is like no charge. Okay, so now we have just taken W as a wood, like this is a one container, we have placed only the electron particles. This is the second, which we have only placed the like concrete particles, and this is the third, which we have only placed iron particle. Okay, so now we just got the chance, we just mix it. Like for suppose here's WSI, like for suppose these are not equally divided, but these are divided, like they're placed in a one container. So what if we need to like find or just separate them, so we'll just take a container, okay, or any glass. What will happen when neutron like electron move angular in momentum, like here this would be W, which is wood, here second would be proton, which is having concrete, and the third one would be iron. Just because iron is very heavy, that will be living in the end. Okay, just because it's very heavy and water cannot even load that much weight. If we talk about the concrete, that's normal, so it would be in the middle. If we talk about the electron, that would be floating, just because it's very like less heavy or lightest particle. Okay, if we talk about the electron also move in an angular. If we talk about here is a W is electron wood, okay, the electron part. So here if I talk about the position of this W, that will be moving with the angular momentum. Just why? Because they like P, like proton is attracting it back. It can even pass throughout the water. How could it pass? It cannot pass, just because proton has a positive charge. Okay, and that is just taking or just going to attract and bring back to its position. That's the reason it cannot go out of that. It can only float just because of that. So this means that angular momentum. Okay, so yes, this was all about today. Thank you.